Hello everyone, I am Adya from Sri Venkateswara College of Engineering, Department of CSC. Today I am going to give you all a presentation on pointeralizing. Overview. What is pointeralizing? Pointeralizing in C. Benefits of understanding pointeralizing. Best practices for avoiding pointeralizing. Real world examples of pointeralizing issues. The future of pointeralizing. Conclusion. Introduction. What is pointeralizing? Pointeralizing is a term used in computer programming to describe a situation where two or more pointers point to the same memory location. In other words, when we have multiple variables that refer to the same memory address, we say that they are aliases of each other. This may seem like a harmless or even useful feature at first, but it can actually cause serious problems in program when different parts accesses the same memory location to different aliases. It can lead to unexpected behavior and difficult to debug errors. Pointeralizing in C. In C, pointeralizing occurs when two pointers at different types point to the same memory location. This can lead to unexpected behavior and errors in code because the compiler assumes that each pointer only accesses its own type of data. For example, if a pointer to an int is cast at a pointer to a char and then used to modify the value of the int, then the resulting behavior may not be what was to be intended. This is because the compiler may optimize the code because on the assumption that the pointer only accesses the char data, leading to the incorrect results. This is an example for pointeralizing in C. Benefits for understanding pointeralizing. Understanding pointeralizing is crucial for writing efficient and bug free code. By knowing when and where aliasing occurs, developers can optimize their programs for better performance. Additionally, avoiding pointeralizing can prevent hard to find bugs that may arise from unexpected memory access. Furthermore, understanding pointeralizing can lead to better code design by recognizing when aliasing is occurring. Developers can structure their code in a way that minimizes aliasing and reduces potential errors. This can result in cleaner, more maintainable code that is easier to debug and modify. Best practices for avoiding pointeralizing. One of the best ways to avoid pointeralizing issues is to use constant whenever possible. By declaring a pointer as constant, you can ensure that it can't be modified and therefore it can't be used to create aliasing problems. Additionally, you should always try to limit the scope of your pointers to the smallest possible area. This can help to prevent accidental aliasing when occurring and make your code easier to understand and maintain. Another important best practice is to always initialize your pointers to null or a valid address before using them. This will help to prevent segmentation faults and other errors that can occur when working with uninitialized pointers. Finally, you should always be careful when casting pointers between different types. This can lead to aliasing issues if not done correctly, so it is very important to double check your code and make sure you are casting pointers safely. Real world examples of pointer aliasing issues. One example of pointer aliasing issues occurred in the development of a video game. The game was designed to run on multiple platforms, including consoles and PCs. The developers use pointers extensively in the code to manage memory and improve performance. However, they soon discovered that the code was causing crashes on certain platforms due to pointeralizing issues. After extensive debugging, they found that the problem was caused by a specific function that was incorrectly using pointers to access memory. They were able to resolve the issue by modifying the function to use a different approach that they did not rely on pointeralizing. Another example of pointeralizing is issues occurred in a financial software application. The application was designed to process large data sets and perform complex calculations. The developers use pointers extensively in the code to manage memory and improve performance. However, they soon discovered that the code was producing incorrect results due to pointeralizing issues. After extensive debugging, they found that the problem was caused by a specific module that was incorrectly using pointers to access data. They were able to resolve the issue by modifying the module to use a different approach that they did not rely on pointeralizing. The future of pointeralizing. As we look to the future, it is clear that pointeralizing will continue to be a crucial issue in programming. With the rise of complex systems and distributed computing, the potential for realizing errors will only increase. However, there are also exciting new technologies on the horizon that may help to mitigate these issues. One promising area of research is type based alias analysis, which uses advanced algorithms to analyze the code and identify potential aliasing problems before they occur. Another emerging trend is escape analysis, which helps to identify when pointers are no longer needed and can be safely deallocated. There are also technologies which hold great promise for improving the safety and reliability of software in the years to come. Conclusion. In conclusion, pointeralizing can be tricky concept to understand, but it's essential for writing safe and efficient code. We have covered the basics of pointers and memory allocation, as well as the challenges posed by pointeralizing in both C and object oriented programming languages. We have also discussed some common mistakes that the programmers make with pointers and how they can lead to aliasing issues, as well as some tips and tools for debugging and detecting these issues. Finally, we have touched on some advanced topics related to pointeralizing and looked at some real world examples of these issues in action. Thank you so much for watching. If you like the presentation, please do like, share, and subscribe.